this is velocity contour from the previous simulation. And I don't know whether you've realized, usually there is a wake developing from the trailing edge of the aerofoil, but this simulation didn't resolve that. This is because the mesh from the trailing edge is very coarse. It won't support to resolve the low speed wake. So can we do that? That's a question. Actually, the answer is yes, because CCM has a very advanced function. It can generate the wake mesh for us. It's called wake refinement. Now let's see how can we do the mesh inside the wake and how it looks like. Okay, so what we do is under the operations, we have the automated mesh 2D, and there's a folder called custom control. So if we right click and choose service control, this is a very amazing thing in the CCM. So for service control, and you can see at the end, there is an option called wake refinement. This is what we want. But before we activate that option, we first need to choose which surface we want to apply. And apparently it should be the aerofoil, right? Okay, so the aerofoil is attached as a surface, and then we just choose wake refinement and enable it. Then we will see some parameters. So click the values of wake refinement. We find the distance of the wake. So the default option is 10 meter, basically to elongate till the end of the domain. That's fine. Let's do this. And the direction of wake is 1 meter along x-axis. That's also good. And also we can choose the expansion spread angle, expansion angle if the wake expands. But now we don't need that. The first sub option is isotropic size. That's 25% of the base, which means the width of the wake. And also we can refine growth rate, and we can make it lighter to calculate. We can make the growth rate 1.5. Okay, so all set, and you can see there's a warning, which means we can execute. Now this is the original mesh, and once it's done, we can see how the wake looks like, or the wake mesh looks like. It might take a while in different computers. Okay, it's working. The good thing is we can see its progress. Now you can see the wake, and the wake mesh is greatly refined, and this will support us to resolve the wake from the trailing edge. Now we do the initialization again. Okay, so in order to do that, it's better to clear the solution, just the vectors, and do the initialization. Now it's 10 meters per second in the entire domain. Then we are set to go. So you can see the evolution of the flow field. Okay, so now the flow is established gradually. Because you have more grades, so the iteration becomes slower. Okay, now gradually we can already see part of the wake, and you can see the extension of the wake also. Okay, now the flow looks more sensible, and the wake also extends to a longer distance. Okay, because of the mesh has a larger size than earlier, so the iteration is slower in each step. You can see gradually the wake extend towards the end of the domain, although the decay is quite severe when it's further downstream. Okay, so you can continue with simulation, and if we compare with the simulation without wake refinement, we'll find a great difference. And of course, we prefer the mesh with wake refinement. Okay, so this is a part for wake refinement to capture the wake of an aerofoil.